Good morning and a big welcome to all attendees to this webinar this morning on technology innovations and solutions for evolving electricity markets in South and Southern Africa. My name is Chris Yelland and I'm the Managing Director at EE Business Intelligence, and I'll be your host at this webinar, signed in today from Johannesburg. And a big welcome also to our presenters who will be introduced to you in due course. I'm also sharing a link to you now in the Zoom chat facility where you can download the presenter biographies. So please take a look at the chat facility on Zoom and you'll see the link to download this the presenter biography. But I'm also going to share now with you a link so you can download the synopses of the four main presentations this morning. And of course, a big welcome to you, the attendees, for your interest and participation today. This webinar is hosted by EE Business Intelligence, and I'd like to acknowledge and thank Bredensen Consulting, Fors in Germany, EnerWeb, and Independent Energy Pool, and OnTech Systems for their most valued support in this webinar and for the great work that they do in this field. We have about 1,100 registrants to attend this webinar this morning to hear what the presenters have to say on the subject. And I think this attests to the relevance of the subject matter being covered, as well as to the stature of the presenters. So may I express a big thanks to all the presenters for their participation and for the significant time and effort they have put in for their presentations today. Please do note that this webinar is being recorded, and links to view this webinar on demand and to download all the presentations will be made available tomorrow morning at about 9 o'clock to all those who registered to attend, as well as publicly. Colleagues, the electricity sector is undergoing a profound transformation, not only in South Africa, but globally. And this is driven by decentralisation, digitalisation, and evolving market dynamics. This webinar explores some of the major market components, part of an ongoing power system market reform, and the webinar will hope to address some of the specific key challenges facing electricity generation, transmission, and distribution sectors in South and Southern Africa. Our four expert presenters will discuss the evolution of technology solutions, including trading platforms, smart metering, utility analytics, and machine learning tools, along with approaches to data mining, demand response management, and integrated demand solutions for the optimization, grid efficiency, and enhanced market operations. From the bidding of renewable resource portfolios using sophisticated forecasting tools, through to scheduling, dispatching, billing, and settlement systems, the webinar will unpack how digital technology solutions streamline and automate operations, enable real-time insights, and drive smarter energy trading. I hope attendees will gain valuable insights into virtual power plants, electricity meter data management, and measurement and reporting systems, which are all key enablers for a more resilient, efficient, and flexible power system. This webinar will provide opportunity, I think, to learn about the solutions, revolutionizing electricity markets, fostering competitive power trading, and unlocking new opportunities for utilities, IPPs, energy traders, and consumers alike. So whether you're involved in policy operations or technology deployments, this webinar is expected to provide actionable knowledge on leveraging digital tools to really navigate the rapidly evolving energy landscape. The program for the day has been widely circulated, but I'm going to share now a link to download the program for today, and I'm going to share it again now on the Zoom chat facility, so please do take a look at that. So the program today is such that first we're going to have an opening address to contextualize the subject. The address is going to be by Mr. Hans-Harold Bredensen of Bredensen Consulting. He is a global expert in the field of market development, and he's playing a leading role in the development of the electricity market in South Africa, and specifically the market code. After this, we're going to have 4 expert presenters who will each give 20-minute presentations. And in between, we're going to have a 10-minute comfort break. Thereafter, we've set aside about 30 minutes for our presentations, or our presenters at least, to answer just some of your questions in an open discussion and Q&A session. So while the presentation is in progress, please do send your questions on the Zoom Q&A text facility, not on the chat facility, on the Q&A text facility. And yes, you may, if we have time, put up your hands and we will take some questions verbally if there's enough time. So without further ado, I'm now going to introduce you to our speakers for the opening address. And the first one, of course, is Hans-Harold Bredensen. Hans-Harold was involved in developing the first market systems at Nord Pool and has since had over 25 years of international experience in the design and implementation of power markets and trading arrangements, as well as in developing new product offerings in evolving electricity markets. He has developed detailed national and regional power market strategies for regulators, power exchanges, and system operators in more than 20 countries worldwide. Hans-Harold is the CEO of Bredensen Consulting, and he's an associate of Nord Pool Consulting, where he was recently the CEO. He's a board member of NODES, the European Marketplace for Trading Local Flexibility, as well as the International Center for Hydropower. So it's given me great pleasure now to hand over to Hans-Harold for his opening words, and it's a privilege to have you here with us today. Hans-Harold, over to you.
Thank you, Chris, and good morning to everybody from most likely a bit colder and at least foggier Norway. So really happy to be here and be allowed to open this seminar. Again, kind of for those of you who know me, I'm a computer scientist of education, even though it has been a while since I've been practicing this. But again, the topic of today of ICT solutions for the power industry has become more and more important for essentially supporting the evolution of the market. And as Chris said, I've been fortunate enough to support not only the South African market reform now for the last, I think, 5 years, but also been part of the continuous development of the Southern African power pool, actually since 2005. So I got a 20-year anniversary on the support of SAPP, and also on what hopefully is going to be launched now within a few months on the Eastern African power pool that can then enable the vision of that you had kind of in Africa from the outset of having a train from Cape to Cairo. Now we can actually soon start to trade power from Cape to Cairo. I'm also doing something a bit out of my comfort zone now as a good consultant. I'm actually going to speak without the PowerPoint presentation. This feels kind of a bit uncertain for a consultant, but I'll give it a try. So again, kind of starting off this, of course, the backdrop of what we are going to discuss today is the market reform process, mostly focused then, of course, on South Africa. That stems from the ERA Amendment Bill and the requirement of creating a more competitive market in South Africa. And try to attract investments into the power sector. As a reminder, and I'm pretty sure, and I see from the attendees that a lot of you are very well aware of that this is the third try for South Africa to do a market reform. So let's hope that the third time is when this is going to be a success. also as a reminder on the market reform itself is, as I very often say, you need to remember that a market reform is a process and not a project. So you need to allow yourself to not try to make everything perfect on day one, but essentially have a strong strategy trying to develop the power market going forward and allow you to take the correct steps, but take it in steps and make sure that you are developing the market in a secure fashion. And if you look at South Africa now, since we started this process, it's of course has a focus on let's say the structural reform. So one of the biggest achievements as of today is of course the creation of the NTCSA with its new kind of units for market operation and the central purchasing agency. And of course these are big let's say structural processes and big tasks for the industry. It has also been a lot of focus over the last, let's say, year and a half on the development of the market code that was drafted kind of starting last year, and as many of you know, was released as a draft version for consultation in April last year. It has gone through a thorough industry consultation, and even though a bit biased as being part of both the development and the consultation processes, I feel very confident that this process, allowing for open feedback to the code, means that the creation of the market design and the market code is sound and fit for the South African purpose to support the market reform here. We have also been seeing, and this is maybe something that is not that visible at this point in time, but again, both the market operator and the central purchasing agency are being established as we speak with an organization and an operational setup with detailed operational procedures. It has been done through an evolutionary process for both of them to ensure that their organization are fit for purpose and shall be able to deliver according to the market code. So all of this is well and fine, and I think this is of course important, but there is still a lot of work that needs to be done to ensure that the market launch is successful. It doesn't help to have a perfect market operator with perfect systems and processes if everybody else surrounding this is not ready. So the obvious one, which is also a process that is ongoing, is the capacitation of NERSA as the regulator that will play an important role and getting the market code approved, licensing in place, etc. But what we are going to focus today is more on the readiness of the market participants, because again, we need to remember that the market is a tool for market participants, and you can see the market as almost like a service provider to the buyers and sellers of the market on how they can do their procurement and selling of power in a more efficient manner. So you can almost look at this as a layered process. So we have now focused on the core, essentially getting the market itself being established, and I think we are well on the way to make that happen. But again, to make this work in a proper manner and making the market launch successful, to get market participants ready, the traders, but also the fundamental players, getting all the stakeholders surrounding this prepared is, let's say, another extremely important part of making the South African wholesale electricity market work. And we have all heard about traders, right? So we see that there are new traders being established and emerging in the South African power sector. But I think one key thing to remind people about is trading is not only for pure traders. Trading is required for everybody that is a fundamental player that needs to either secure their requirement for power as a consumer or secure a longer term price for its generation. And I think it's important for everybody to understand that even though that you are an ESCOM generation with the vesting contract, or if you are a small IPP that either goes directly into the market or will soon be subject to market prices, you need to have a strategy for how you make this or how you manage your market access. And while the wholesale market will provide the short-term prices and ensure balance between supply and demand based on essentially the day-ahead orders from market participants, this is a way too risky setup for any fundamental player. To only know the price one day ahead, I think we all can agree that that is a too risky setup. And thereby, the requirement of other trading venues will emerge and have to emerge to support the strategy of any buyer or seller of electricity. For those of you who follow the market consultation workshops, you will hopefully remember that I joked about that if nobody will set up a longer term market like an OTC or a financial derivative market, I'll come down myself and do it. Today, we hopefully will hear from somebody who's willing to take this challenge, so I don't have to do it myself. It is also kind of, as I said, very important to understand that everybody or anybody that is buying or selling power, essentially generating or consuming, they are trading. And it's also very important that all of these should have a trading strategy, meaning that they need to understand how they interact with the market or how they are going to procure or sell power, what is the risk that they are seeing. And also one of the key things that makes this complicated is that a trading strategy is specific for any company. So there is no, let's say, no strategy where there's one solution fit for all. But I would like to stress again that all, let's say, serious companies should have a trading strategy. Of course, just a simple example is an energy-intensive industry that needs to secure its power. They know that they will have a rather steady requirement for power for 24/7, 365 days a year. But based on what shall I procure my power? Shall I sign a long-term multi-year PPA of physical power? Should I try to make it financial? Should I have any strategy towards buying or selling power in the short-term market? These are decisions that will ultimately affect kind of your profitability at the end as a company. And therefore, again, even though that what can be seen as a very simple kind of setup, there are some decisions that should be made by these companies. And again, many of you have heard me tell this story before about Elkem, a Norwegian energy-intensive company back in the late 90s. They produced, or one of the main outputs is aluminium. And in 1998, they earned more money on trading power than they did on producing electricity. So even though what should, or from the outset could be seen as a pretty stable consumer of power, by having a trading strategy and having people that were following the market in a bad, let's say, aluminium year, they were still able to earn money on trading. So what we have seen in other markets is that you need these longer term products, and they will emerge very soon after market launch. And then again, of course, it's the question who and how this is going to be implemented. In many jurisdictions, this is going to be or have been decided to be centrally set up. So again, you give the task to a market operator. In others, it has been more driven by private initiatives. So again, I think it's clear from the outset that the South African wholesale electricity market will be the shorter market, and that these other markets ideally should be set up by others. And again, in Norway, we saw exactly this happening, where two bright guys saw after the launch of the market that there is a need for longer-term price security. A longer-term fiscal bilateral contract is not giving that flexibility, and they essentially started a very small but very soon successful initiative to launch a financial OTC market that ultimately was taken over by Nord Pool, and this is now what we know, the Nordic financial derivative markets operated by Euronext. So today we'll hear some presentations of experience from Europe, but applied to the South African context. We will hear about the experience from an ICT company with trading solutions for the Southern African power sector. We'll also hear from somebody who listened to my request for a longer-term market. And finally, we'll hear a story on what is and will become an even more important part of the industry: data and the whole ecosystem around metadata, and how you can utilize that in part of or as part of your trading and your trading strategy. So again, the focus, as you also heard from Chris, is on ICT solutions, and of course why and how this should be an important part of the South African or Southern African power markets going forward. But I will also remind everybody what I've spent most of my introduction talking about, is that remember that the market is a tool. Likewise, with the ICT solutions, they are a tool. But if you don't know why or how you are using these tools, it won't help you. So that is why I say tools are fine, but knowing how to operate them is also equally important. So have that in mind when you listen to the presentations, that creating and maintaining a strategy on how you are going to enter into the market and be a market participant is equally important as having a lot of nice tools. So with that, that small challenge, I'll hand back to Chris and allow the other speakers to start talking.
Yeah, thanks so much, Hans Errol. Hans Errol, we are honored to have you here. To have somebody of your deep experience to assist in setting up this market. You've explained it so eloquently, the complexities and the benefits. And as you said, third time lucky, we hope. We've tried twice before and it hasn't succeeded. It's absolutely critical, in my view, that this should succeed. Otherwise, we might take a 20-year backward step. And we saw what happened with that with Medupi and Kusile the last time we took a 20-year backward step. It has devastating consequences. Thanks also for your advice that we not only need the right tools, but we need to know how to use them. We need capacitization of not only the regulatory framework and the regulator itself, as well as market participants. They need the right tools. They need to know how to use them. There's still a lot of work to be done, as you've pointed out, and I think you've set the scene perfectly for what is to come. And the first of what is to come is the presentation by Mr. Martin Hiller, who is the managing partner of FORS in Germany. And Martin is an energy and commodity trading expert and the head of consulting services at FORS. He has led projects across Europe and Africa, supporting utilities and trading organizations, shaping their strategies and identifying business opportunities in energy markets. Martin has designed and established energy trading organizations for clients, and his particular expertise is in energy and trading risk management systems that enhance long-term and short-term trading, as Hans has explained the needs for these. And he's also been developing trading and pricing strategies for different commodities such as power, gas, certificates, etc. Martin has also contributed to power market reforms in South Africa, Georgia, and Lesotho. It's countries as diverse as that. And he's established competitive trading organizations and regulated power market entities. So again, somebody with global experience, somebody who can share this knowledge in the South African context. Great to see you, Martin, signing in from Germany, and over to you for your presentation.
Hi, Chris, and thank you very much, Chris, for the introduction, and thanks to Hans as well for the great introduction. And I'm very pleased to be part of this webinar. It's my very first time, and what I can maybe just add to your introduction, Chris, is that together with Hans, I had gladly the opportunity to be part of the design of the CPA, the Central Purchase Agency, but also the international trader and the market operator of the National Transmission System Company of South Africa. So that gives me a lot of exposure to the South African energy context, and fueled by the experience of more unbundled and developed markets like in Europe. I hope I can bring something very interesting on the table for today. That brings me to the topic of today. So what I would like to focus on is on the South African wholesale energy market, in short, SAWEM, which is envisaged to be launched in April 2026. And I would like to focus on some particular market components, especially the day-ahead and intraday market, and how it can be used, especially for independent power producers, to participate in the market and to utilize an opportunity there. That will come down at the very end to systems, technology, processes, and so on. It's a big and wide field to be able to participate in trading, but I hope I can boil it down to the most relevant and most important things that need to be built up and there in order to participate in the day-ahead and intraday market. So that's in short the story, but let me dive into it. Let's first look at the holistic, the general design of the wholesale electricity market in South Africa, in short, SAWEM. And I will focus on the three upper ones, so especially the energy market, the day-ahead and intraday markets. But what comes with it, what is linked to it, is the participation in the reserve market and also in the balancing market. Beyond those three components, there is also other market components, as you can see on the bottom here, which are important to establish and maintain a fully functional power system and power market in South Africa. And I would like to focus on one key question in the following minutes. So what does it require, especially as an independent power producer, but it can be any trader or market participant, to participate in the energy market, which means predominantly in day-ahead and intraday markets. And the underlying use case or business case can be that I, as an IPP, have an inflexible generator like a wind or a solar park, and I'm asking myself the question that you, Hans, outlined: shall I enter into a bilateral physical power purchase agreement, PPA contract, to sell off my energy? Or shall I maybe go a different strategy? One of it can be I directly participate in the SAWEM by participating in the day-ahead and intraday markets to sell off the electricity from my inflexible wind or solar generators. Another and a very interesting use case or business case can be that I have a dispatchable generator, for example, a large-scale battery storage, or it could also be, let's say, theoretically, could be also a gas peaker. So compared to the renewable wind or solar generator, I have the huge and great opportunity to influence the dispatch. So how I put it in the market, because I can, for a battery, clearly decide whether I charge or discharge given on the expected market situation. I hope I could set the scene nicely now. So two components, day ahead and intraday markets, and then we look into what does it take in order to participate there as an IPP. To do so, let's have some closer look into the day ahead and intraday market that is being worked out since a couple of months and years even, and will be launched as per plan now in April 2026. So the day ahead market in South Africa foresees that there is one day ahead auction. This is this light green part here. And this day ahead auction happens the day before the physical generation and delivery of the electricity in the grid. It shall happen if you're a participant, you need to submit your day ahead auction bid at 10 o'clock the day before. There you need to tell basically the market operator, this is my intended availability, this is my capacity of production if you're a producer, these are my marginal costs, together with some other information that are important for the market operator. But this is basically the point in time where you say, hey, I'm there as a generator, and these are the parameters for my electricity that I want to sell off in the market. At 2 o'clock, 2 p.m., the market operator will then publish the auction results. There you see then basically how you're expected to produce electricity in very short. And you will also see what the financial compensation for this is. But this is not the end of the story until the physical delivery or generation, because there will be 4 intraday auctions. This is the dark green part here. And what is happening there? It's also auction style as with the day ahead, but the timing is different. And the first intraday auction and the deadline for submitting your bid will be at 6 p.m. the same day as the day ahead auction happens. So still the day before physical generation. And the hours for which you participate auctioning your generation will be 6 hours of the following day. So the first 6 hours from 12 midnight to 6 a.m. in the morning. So you auction for those 6 hours. And if you're a producer, you're putting your generation for those 6 hours into the market. If you now have already participated in the day ahead market, you might have good reasons, and I come to that later, to say, well, my expected production and availability has changed, and I need to let the market know by this, that I can change potentially my bid in a way that it's beneficial for myself. And in a similar way that there is then a second intraday auction at midnight, and that applies for the hours of 6 hours again of the next days, so from 6 a.m. in the morning to 12 lunchtime. The next day, so that's always the D-Day, I call it, the day of physical generation. And then the third intraday auction has its deadline for bid submission at 6 a.m. in the morning. That's already then the following day, so the day of production. And it auctions on the 6 hours starting from lunchtime to 6 p.m. in the evening. And the fourth intraday auction has its bid submission deadline at 12 lunchtime. That's already on the day of physical generation. And the the hours that are auctioned as part of this intraday auction are from 6 p.m. in the evening until midnight. So maybe as a key summary, important to understand at this stage is that both the day-ahead auction that happens 10 in the day before the physical generation, and all the 4 intraday auction focus on the same hours for physical electricity generation. So they focus on 24 hours, and the day-ahead auction has its deadline for submission the day before, and the 4 intraday auction, they focus partially always on blocks of 6 hours. They happen partially the day before, but also during the day of physical generation and delivery. So I hope this could set the scene a bit and give an insight on how the market design is intended. And now I'm diving into what does it mean for me now as an IPP, for example, or as general market participant, also a pure trader. What does it mean for me now to participate in the market? What do I need to have in mind there? I think I did some yeah, okay. So let's focus on the use case. I'm an IPP and I have an inflexible generator, mainly a solar park or a wind park. And in order to participate in the day-ahead auction, you need to provide certain information to the market. And not to complicate it, but to boil it down to the most important things, you need to know basically your generation forecast. So what are you intended to produce as electricity? And of course, you need to know your marginal costs. And those, along with other information, those information you need to provide to the market operator. And for that reason, of course, you need to have ideally a very precise generation forecast, because you might be facing penalties or fees if you provide a forecast that is very much off. So it's important to know that the generation forecast should be good. Then moving ahead, if the time elapses now and we're not only at 10 a.m. in the morning, but now at 6 p.m. the same day, but facing the submission deadline for the intraday, for the first intraday auction, there you have the possibility to redeclare. And what you can redeclare is the volume. So in case between 10 a.m. in the morning and 6 p.m. in the afternoon, you realize that due to new weather forecast, that your generated electricity will be different than the one you communicated before to the market. Here, then you have the opportunity to redeclare the volume for the hours that are part of the delivery period of the first intraday auction. And again, that means you need to have the features in place, the capabilities to come up with a precise intraday generation forecast for those 6 hours that are part of this intraday auction. And then to move forward, I guess you can maybe anticipate what is happening if now the deadline occurs or gets closer for the second intraday auction, which is this delivery period. Again, you need to have an updated generation forecast for your solar or your wind park. And in case the auctioned hours change based on your forecast, that you produce more or less electricity, you can redeclare this to the market. And this will be the same then for the third intraday auction and the fourth intraday auction. So to summarize it, and I'll dive deeper into what this means and what are the challenges behind this process. But to summarize, you can see that there is 5 big events happening, let's say, in the market, the head auction and then the intraday auctions, that you need to build up and embed in your trading process from front to end. And one key aspect is to be able to produce a generation forecast, not just once, but almost continuously during the day. And ideally in a very automated fashion, because you don't have much time to update or redeclare your generated your forecast generation. But I'll come to that later. Before we get there, I would like to focus on a second use case. This is now again maybe from the perspective of an IPP, but you're not now looking at your wind or solar park, but on a dispatchable generator. So on a generator where you have a strong impact, basically you can decide how you dispatch and how you run that generator. And that can be a gas peaker, but it could also be a large scale battery storage system, a BESS, for example, where you can really decide, do I charge my battery now and pay the price that I'll see in the market? Or do I discharge and earn the price in the market? And this use case follows the same market procedure, of course, than with the solar and wind use case, but it's much more, let's say, delicate or important, time critical, complex also for the IPP. Because for the day ahead and also for the intraday bid submissions, you need to have a generation forecast, but basically you can create that generation forecast to some extent because you have the possibility to optimize your dispatch. So in case of a battery, you need to provide of course, the availability for discharging, but also the availability or the capacity for charging, together with the marginal costs. So the price that you want to have in case you discharge and provide electricity to the market, or the price you're paying in case you charge and consume electricity. So you need to know and have a trading strategy for yourself to understand how much of my volume should I put into the market and what is the price that I want to earn at least. And this is more complex from a processal point of view and also from a modeling and know-how point of view. So if I participate in all 5 auctions and have this embedded in my process, this requires that I have the systems in place, the expertise in place, the modeling know-how in place, the technology in place, the systems in place, so that this process happens ideally in a very efficient and very automated way. So that's the overview of how you as an IPP can participate, but in general, any market participant can participate in day and intraday markets. So what does it mean? Illustrated along 2 major use cases with a inflexible and a dispatchable generator. And what I can state at the very end here is that it looks simple on the slides. I have those 4 boxes in orange, but in order to build up a trading organization that is good in participating in day and intraday markets and does it in a way that it's not creating a lot of manual efforts, operational risk, and especially focusing on getting out most of the market so that you put your generation in a most beneficial, most profitable way into the market. This means that you need to have a lot of things in place, the right organizational structure, the right systems, the right technology, the right data, and managing data well. Modeling capabilities are important, especially for forecasting. You might apply machine learning methods there. And of course, you need to define your processes very well, especially in operating model in case something goes wrong in this time critical process from day ahead to intraday auction participation. So that's my key statement at this point, and there is colleagues that follow my presentation that shine a bit of an insight into the right systems, technology, modeling approaches, and to end my presentation and my part, I would like to put the whole market participation in a bigger view. Before you may decide to participate in the market, day ahead and intraday market, you might wonder yourself, well, what is my underlying business case? Does it make sense for me to participate in the South African wholesale electricity market? What are feasible and profitable business cases behind it? And that, I call it, this is the South African power market entry journey from strategy definition. What is my vision, my strategy? What are my business cases that make sense economically, but also ecologically maybe? And then understanding how can I enter this market? So how can I build up an organization that is that can participate in day ahead and intraday markets and potentially other market components? And this is a whole journey and a whole process. And I hope and I'm sure that colleagues follow me will shine some insights into what is needed from an especially system and technology aspect. Back to you, Chris.
Well, thank you, Martin. I thought it was a wonderfully clear description of what the day ahead and intraday markets require for participants. And for me, the takeaways are, first of all, the very time critical nature of this process, very defined time slots. Even when you're bidding, you've got to bid, I presume, for every hour a day of the day or half hour of the day, whatever. But all of this is very time critical, is very data intensive, and
Yes,
there is a need for automation. There is no way really that I can see you're going
absolutely.
to be a participant every day of the week, every hour of the day, with 4 bidding processes per day, unless you've got high levels of automation. And that's what we're going to talk about further. So I think you've set the scene. You've made it absolutely clear what the requirements are to participate in this market. And it's been absolutely fascinating and a privilege to hear from somebody who can present with such clarity and such brevity. To do this in 20 minutes was, for me, very deeply impressive. So thank you very much, Martin, all the way from Germany. Wonderful to have people that can join from all over the world in these kind of discussions. So it's a pleasure now to introduce you our next presenter, and that is from South Africa. Dr. Gerard van Harmelen, who's the Chief Innovation Officer of the company EnerWeb, who've been a participant on our webinars before. But Gerard co-founded EnerWeb in 1999, and he's currently the Chief Innovation Officer focusing on the trading and wheeling environment. He's been involved in the electricity industry for 25 years and in the trading environment since the introduction of Eskom's internal multi-market model trading initiatives in the early 2000s. You've heard about the earlier efforts described by Hans Arold, in the market development, and Gerard has been involved all along the way. He has authored and co-authored more than 50 local and international papers, primarily in data analysis in the fields of load research and demand intelligence. Gerard has a Bachelor of Engineering degree, a Master of Engineering, and PhD degrees in electrical engineering, and his key skills include electricity trading systems development, as well as electricity trading analytics, including portfolio and wheeling simulation, forecasting and optimization. So we're now getting right into the nitty-gritty of the tools that are needed, tools that Gerard and his company have been developing over the years. So great pleasure to introduce you, and over to you now, Gerard.
Thank you, Chris. Good morning, everyone. Thanks for Hans and Martin. Yeah, very, very good introductions. Thanks for setting me up. I hope I don't disappoint, but thank you for that. Yeah, our presentation is then a little bit more on the nitty-gritty, as you say, and sort of getting into the types of things that actually provide this sort of capability from a systems perspective, not from a business or a process perspective, but to implement those processes, but from the IT sort of solution side. And Interweb's been around since the early days of sort of the initial trading. Interweb actually got founded on top of these initial attempts at deregulating the local market, but have been involved in the Southern African Power Pool, providing the market platform there, and then also now the East African Power Pool. So we've been around for 20 years and have been very much part on the system side of this evolution of sort of the IT and the solution side. But my slides, I'll give sort of an introduction on just how the business has evolved and the 4 core areas which essentially evolved out of this market deregulation and trading. So you'll see in our business. And then I'm going to present essentially slide 3, 4, 5, the sort of sample algorithms or sample, I wouldn't call them innovations. Sometimes they are innovations, but some of the advanced, I'll try and keep it simple, but the technologies that get used that make this stuff, the automation of it possible, make the sort of advanced optimization, making these very complex things, how we use essentially IT systems and algorithms to help participants with this high degree of automation and time criticality. And then just in the last slide, we've seen, just as I suppose as a result of us being, privileged to be around for the last 20 years and see this evolvement, but we've seen various stages of solutions, different types of solutions and in different participants as they evolve. So we'll give one slide just sort of on our exposure and what we've seen in the industry happening. And what people have been using in terms of the IT, how they start off and how they figure things out. So just in terms of Interweb, this is the sort of the core slide of just what the business is about. And I think up front, the key point here is that Interweb is not a trader. We are not a direct market participant. We're not a market operator. We're not a power exchange, even though we are providing to those participants, whether you're a market participant, such as an IPP or a trader, or you're a market operator, as in the Southern African Power Pool or the East African Power Pool, we provide the background, the participant systems, and the platforms. So we do that, but we don't take a direct role in any of these transactions. So we remain an IT systems and solutions provider. The 4 business areas, I think if I can get a cursor going, let's go with this one. There we go. I hope you can see. So I've sort of got a pointer there. So there's 4 business areas that essentially evolved, I think, out of, this trading market sort of space. And the 4 core areas, these remain our 4 business areas, are sort of the demand response, virtual power plant area. And in that specific, I'm just going to go around the clock as they go, but there we've been providing these reserve market participant solutions. So this is Eskom we've been providing managed services to Eskom and its big customer participants, where there are literally 1,000 megawatts that participates on this internal reserve market for Eskom. So that we see evolving into this battery energy storage, although not yet, but very close, I think, on the Eskom side. So virtual power plants, and we see, there's this big expectation of these ancillary service aggregators that'll happen in South Africa and in the region. But the IT side and the solutions for this has been a core business area, very, very, I think about 10 years we've been providing these managed services provisions on behalf of Eskom to its participants. On the energy data solutions, the top left hand or top right hand one, this has essentially been the core of sort of the start of Enoweb, the metering data side of things. And there, as a result of our involvement and our start off, I mean, Enoweb started off as a business unit in Eskom 20 years ago, but privatized, sort of in the 2010s, I think, that sort of space. The meter data management systems themselves to handle these volumes of meter data, not the collection of it, but the management once the data has come in. And an esteemed colleague of mine, I think the next presentation, I think it is, will talk about the big advancements in sort of metering technology and the collection of that. But Enoweb as a core competence and is providing systems on the meter data management side, support for these systems, the head ends and operational support for that. Very strong capability on integration, enterprise integration, once these systems get into your or need to be integrated into your business and into your ETRM or into your market platform. And then obviously of late, nice capabilities are coming to the fore on technologies in terms of multidimensional cube sort of dashboarding of all this metering data to make it easy to digest and to present. So that's sort of the second business area. Third business area, been very prevalent in Enoweb over the last 15 years, is the utility analytics space. That's where I come from. And this is sort of where I suppose some of the more buzzwordy type of technologies and algorithms are present. And so trade optimization, the one that Martin spoke about, this very complicated process about this portfolio management and optimization. Well, what is that all about? Or you can call it there's a spelling mistake. There should be energy allocations. The energy allocations, how do you allocate those energies? So the optimization tools there, the risk modeling, there's a big word there, but essentially what are all the scenarios, like running thousands of scenarios depending on the variability of, let's say, the weather for tomorrow or for next month or for next year. Running these and then making strategic decisions on tactical decisions at that point. Operational decisions are shorter, but making tactical decisions around how to manage your portfolio and what are the risks, actually quantifying numerically the risks in terms of profit at risk or whatever that you're looking at. And then the AI, machine learning buzzword has been around a long time. It hasn't had those buzzwords, but machine learning algorithms is sort of a core competence for doing these types of forecasts, renewable plant forecast, or even a customer load forecast, depending on that. So that's the third core area. And then the fourth area that I think is probably most relevant. Where's my cursor gone now? Let me try another cursor. I got lost. Anyway, where's my cursor? The fourth area on the bottom left-hand side is the enterprise solutions that Enoweb provides, both for participants, those are called the ETRM systems, energy trading and risk management systems, and then, for instance, in the SAP case or in the East African Power Pool case, the actual platform itself, the platform where participants participate, the clearing algorithms, the auctioning algorithms, and depending on the type of market that's run. We've been talking about auction markets today, but for instance, there's these continuous markets where it's not clearing algorithms, it's sort of, place bids and offers, and you can hit bids and offers, so continuous market. And then in that space, we do these enterprise implementations and change management into the businesses, and then operational support of those platforms. So into the sort of nice part, the sort of nitty-gritty of things. I've drawn this diagram just from a sort of to give context in terms of, what are we talking? What are these sort of major areas with the participant? It doesn't necessarily have to be a trader. This can be a large consumer with an energy management department, for instance, or it can be a trader, an aggregator, can be an IPP, can be utility single buyer, but they all, so this entity is sort of the participant. Let's call them the participant, and they interact in sort of four main sort of interactions that I've sort of categorized. The one is with the generation side, with generators or the production side. If that they have contracted or that they want to buy from, or if you're, for instance, an aggregator, you might have long-term PPAs in place with them. So there's sort of, you have these interactions with your generation side. If you're a trader now, maybe if you're a generator, maybe this is your might be internal even, but okay, the generation side, the consumption side, if let's just focus on the use case of an aggregator, let's say, on the consumers that you have signed contracts with, or that you're going to be participating on a market, one of the markets, you're participating on behalf of them and trying to balance your portfolio, give them good prices and reduce their risk and give them commitments in terms of renewables. But there's this consumption side. You have a major interaction sort of requirement to interact with markets, with the different markets. And we've heard now this morning, there's the sort of centralized regulated NTCSA, which with anticipated time, but there's this expectation for these OTC markets that will pop up, and I think we hope to see a little bit more about that. We will see, I think, the last presentation. And then there might be more than one market. There might be the local market and the SAP market, and the linking of those. And I think the two markets will link between each other. But you have this interaction requirement, depending on how you manage your portfolio, with the maybe more than one market, even at the same time. And some of those markets might be complementary to each other. For instance, an OTC will support maybe the main regulatory market in South Africa. That might be the way that goes. So you could first participate on the OTC maybe 2 or 3 days ahead or a week ahead, and then as the time gets by and you've got a little bit left to do, a little bit of outstanding imbalance, then on the day ahead, the official day ahead market. And these markets, as I think you've heard Martin spoke about, have these different sort of time spans and different categories and different rules, requirements, and sort of time gates associated with them. So once again, you as a trader have these three, and then the metering data side, which shouldn't be underestimated. So, there's this requirement to interact with metering data space. And in metering data space, maybe there's three categories, maybe there's more, but sort of three main ones. Maybe you have your own meters. You might even have, or you might be contracting someone, or you might even have your own sort of metering data collection system. So that might be internal, but there are several very, very professional metering data service providers whose business in South Africa are to install and collect the metering data from, some of these providers have literally hundreds of thousands of meters that they service currently, and they do that in a very, very professional way. But you as a participant then need, good integration interfaces and good capability with these metering data service providers, typically via API. And then the utilities. I've just put Eskom here, but these utilities could be one of the municipalities, for instance, could be City of Cape Town's internal metering data systems, or if it's an Eskom as the distributor, maybe the Eskom distribution sort of metering data management system, they would be managing internally their metering data, and they would have one of these, or NTSA or transmission then as well. So there'd be these integrations. So these are the four sort of main areas that are very important. And you'll see here from the top, I've sort of put as input, depending on how much of this analytics you're doing internally, and how much of it is purchased. You can buy forecast, but all this forecast data, price data from the markets, from the NTSA market or from OTC market, are all then inputs into sort of your analytics platform. You have your, let's say, section of your environment, your transactional section, which is doing all your scheduling, all this integration, all the settlements and the billing and the invoicing happens in the transactional platform. And then typically you have a metadata management environment, metadata management platform inside of yourselves to handle this. Even this gets to be very, very onerous, these inputs from all these different sets. Okay, let's get in. So I have 3 examples now, just of some of the nice sort of technology stuff. I'll give one example of technologies being used in MDMSs. We'll talk a little bit about this trade optimization thing. What is that? And then also just an overview on how these market platforms, for instance, the SAP market platform, does congestion management. So on the meter data management side, The nice technology that gets used here are these business rule engines. So it's the business rule engine is essentially, I think, a way that, it's a way to process and transform and officialize data coming from the sort of devices on the left-hand side to your official systems on the right-hand side. So the official systems could be billing systems or these ETRMs on the right-hand side. And taking this data through these stages from multiple sources is what these business rule engines make very nice, very easy for you to do. So the business users or the business analysts can use business language with these business rule engines to configure the rules within the business rule engine. So rules cover things like validation, ranges, spikes, subsequent zeros, this type of, if you find that, what must you do with it? The editing and correction of values, sometimes these settlement processes and pro forma billing or actual billing is very critical for, is very time sensitive. So sometimes you can't wait for the metering data. So you have to make an official, sort of process and rules for how you will handle missing data, etc. So the editing and estimation of missing data, the creation of new data sets. For instance, if you want to use your metering infrastructure to work out renewable certificate energy that qualifies for renewable certificates, or savings for the customers, or want to dummy the utility bill, just the metering part of it, the metering. So you have these business rule engines make it very easy for you to sort of specify that in business language and create those metering profiles. And then approval workflow is very important. So verification and approval processes, as you'll see, and editing and estimation approval process. So when does the data go through and when must it pass via, as part of the business process? Must it pass via administrator or an analyst? So these engines, they provide, this automation and this transparency and auditability to manage these large volumes of metering data sets, half-hourly metering data sets, or maybe even faster, depending on the markets. And then they produce these official data sets. The second example is the one that I think Martin also referred to, is these optimizations that help you to figure out, bids and offers. So even in the bilateral sort of wheeling world, which we currently have, this energy allocation problem for a portfolio, a few generators to some consumers, is not a trivial problem. And so if you just look at the block diagram, depending on, you have different solvers for, depending on which market, that bilateral market, or let's call it the wheeling portfolio, and you may then have a day ahead, or let's say a shorter term market portfolio. But you have all these sort of sometimes conflicting objectives. You have sort of metering data coming in on the left-hand side. You have forecasts on that metering data or the states of your batteries. You have pricing, which you've agreed with on contract with customers if you're in the wheeling market, or the pricing forecasts on some of these shorter-term markets. You have regulatory constraints. For instance, the difference between what Eskom calls traditional wheeling and portfolio wheeling. They are, I've referred to those as, but they're constraints in terms of the framework that you have to, how you have to perform these allocations. There's contractual parameters and guarantees that may be different even to different customers, and you want to balance and optimize this portfolio given some objective function. Objective function for, if I use the use case of an aggregator or a trader, is maybe in the first few years it's market penetration. So in that case, maybe the sway of the let's call it the profitability, or is compromised in favor of market penetration and gaining customers. But later on, it might be profit optimization, might be cost minimization for its customers. So there are these different objective functions that the trader can use, and those different objective functions then get optimized and come out as these energy allocations, or even as energy bids and offers onto the markets. So that's what this typically these solvers are solved by linear optimization algorithms, and there's a couple of you choose a solver. There's a couple of commercial ones around Cplex or Garobi, maybe you've heard of these, and there's a couple of open source ones which are not as fast, but they can also do the job. And then this problem is then formulated into a mathematical equation, essentially a big, huge equation for the objective function, equations for all constraints, and this optimizer then solves that. And you can run this in tactical mode for a month ahead, week ahead, and then in operational mode, depending, maybe day ahead, when you have more of the constraints sort of in. And then post-processing, obviously, the outputs of these then go into scheduling, submitting bids, telling the TSO what you have decided for the previous month, which generator is allocating which energy for which time of use period, let's say, for which customer. So these are typical post-processing outputs for this. On the last one, just in terms of the electricity market platforms that in a way provides, this is a very sort of one of the interesting ones. It's the congestion management one. And the problem here is to sort of figure out whether bids or offers in one area can connect or can provide energy to another area. So if you look at, for instance, in area A, maybe there's a cell offer there for a bunch of volume, but the interconnector between and they want to get the energy, the potential buyers are in area D, but the interconnector between A and C is at full capacity. So these algorithms figure out that there is another route, and is there sufficient capacity on this other route from A to B to C to D. So they bypass this interconnector that's already saturated, in terms of capacity. So these interconnector sort of capacities are worked out by clever electrical engineers doing these flow studies. The bids and offers come from the market, so all the participants put the bids and offers into the market, and then the algorithms find these routes, between let's say offers and potential bidders. Can that actually be a valid transaction? And the market the market's platforms have these engines that can solve this and can constrain bids and offers, and they then also allocate capacities on these interconnectors. They maintain sort of a running total of the capacities of these. So in interregional trading, as we have in SAP, this is very much sort of active at the moment. This is part of the sort of the whole process. Not currently within South Africa, but the official market operator and TSO will be doing this internally. And I don't know, I think some of this will eventually get shared when when transmission constraints between areas within South Africa start becoming a problem. Okay, and then in terms of just my last sort of slide, just as during our tenure being privileged to be in this environment, we've seen, and I think this is specifically relevant to the current traders and aggregators that we see, I'm targeting those specifically here. They go through these life stages or life cycles, with being market entry, where you sort of figure out there's a business going to happen here, an aggregator business, let's say, and you want to see that this is a business. So client interest, this sort of letters of intent, this sort of happens in the market entry phase. And then there's a capitalization phase, where you have to secure your financial and regulatory base and licensing and market access. Step 3 is product penetration, where you're sort of starting to figure out your products and what you can offer and the pricing. And then there's a stabilization phase, where you really start sort of operating, and then finally you're growing your business. So this is just background to my following slide, which I want to get to. But there's these 5 stages, and you'll see these, or that we've seen. And these 5 stages are now, you'll see in the second column: capitalization phase, product penetration phase, stabilization. This might take a year or 2, depending on the trader itself, and then market expansion phase. And I've sort of put characteristics of each of those phases, IT characteristics or solution characteristics, as the specific column. Initial cost, speed to implement, in the product penetration phase, when you're thinking about products, you want to be able to change rapidly, you want reporting, but the point of the slide is that in these different phases, different types of IT solutions that we've seen are more appropriate. And I think in each case, I think we've done quite a few now already. It always starts in Excel. So the first column, in your capitalization, even a little bit into your product penetration, Excel can do quite well. Second sort of level of sophistication is where you start to automate Excel, and you put macros around it and scripts, starting to handle a bit of volume. And it's, in that phase, the product penetration phase, very, very useful. Even into, we've seen customers build little POCs and do a bit of the internal development to try out things. And I think it is more applicable in that product penetration phase to do that type of solution for yourself than to sort of go all the way to managed services or to buy an enterprise solution, because you don't know what those, and there might be what they are, and they might be evolving very rapidly. But then in the market, in the stabilization phase, where you're starting to operate, you know what the products are, you've got customer sign-in, then the enterprise solutions, local or international, become worth it. And the sort of managed services side of things, where the vendor starts to help even on the performance of your IT solution, your business process performance, are preferable. And then on the last one, in the market expansion phase, you can sort of do a mix of that and focus different things on different places, with the managed services being sort of the very top end, but where the solutions and the IT doesn't only focus on sort of IT, it becomes part of the business process, and you can put performance contracts on the service provider, for instance, in terms of configuration or fast settlement or on-time submission of bids. We've seen all of this. So I'm going to skip this one. Just in summary, then, we've sort of presented anywhere but the four business areas. I think very much, it's just we've been privileged to be there, but that in support of this market and the involvement of this market. I gave the slide with the four areas that a participant has to interact with, and then examples in metadata management system, the business rule engine, in the energy trading portfolio optimization, the energy allocation problem, and the linear optimizers that are used there, and then the congestion management problem that electricity market platforms have to solve and share with participants, and then just the evolvement from Excel all the way to managed services as the traders, which was the use case, then evolve. That's it. Thank you very much.
Yeah, thanks very much, Gerard. I think you've explained, some of the platforms that are needed and some of the tools and the solutions that you provide, from market platforms, whether it's over-the-counter platforms, which we're going to hear about in our next presentation, day-ahead platforms, intraday market platforms, through to participant tools, whether you're a generator trader or an end customer, demand response tools like a virtual power plant, where you're not adding generation, you're actually reducing demand as a response, a market response. Transactional and settlement platforms. I mean, can you imagine all these thousands of transactions taking place that have to be settled? Money has to be transferred, or whatever accounts need to be updated. Huge, requirements there. Metering data platforms you've talked about, and our next present, or our fourth presenter, is going to be talking about some of that, and then of course your analytics platforms, where you gain visibility and to what's happening with all this data. What strikes me about all of this gets to the heart of digitalisation. We hear these words, but this talks to the digitalisation of the electricity sector, this power sector. Power engineers are not noted for knowing too much about data, but you start to understand that data becomes absolutely critical, and automation and all these different platforms that have to talk to each other and work. And lastly, this question of algorithms to automate, intelligent algorithms that meet specific objectives. The objectives can change, as you've pointed out. They need to be optimized. It's a big optimization process. You've talked about that. So I think you overran your time, Gerard, but nevertheless, I couldn't stop you because it was just so important and relevant. Thanks for some great presentations so far, and some great presentations still to come. I also want to thank our presenters for helping me answering the questions. A lot of the questions, in fact, all but one, have been answered online, and this is fantastic. It's going to leave us extra time, to answer some verbal questions where people can put up their hands and ask questions. But it's now my great pleasure to introduce our third presenter, and that is Holger Janker, who's also been a presenter on a previous webinar of ours. He's the Chief Executive Officer of the Independent Energy Pool based in Switzerland, also very active in South Africa, of course. Holger Janker has over 20 years of experience in the energy sector, including a decade of expertise in the South African renewable energy market. He was an architect of Africa's first renewable energy bond and is one of the founders of the Independent Energy Pool. Holger was instrumental in building the marketplace and the underlying rules and standardized contracting arrangements for over-the-counter market. So this is now taking these presentations a step further. We've looked at the market platforms, and now we're going to be looking at some of the over-the-counter platforms, over-the-counter market platforms, OTC market. Holger has held various managerial roles within EPC companies, equipment suppliers, and technical consultancies, with a very strong entrepreneurial focus in large global intercultural organizations, as well as early stage startups. Holger has a master's degree in mechanical engineering and business admin from the Technical University of Darmstadt. So fantastic. Great to have you all the way from Switzerland, Holger, back in South Africa, well, your face anyway, and over to you. Thank you.
Thank you very much, Chris, for the introduction, and happy to be back on this forum. I think it's my presentation is a good continuation relative to the previous presentations, and I will try to keep it short. I will focus effectively on the topic of the OTC market and how that relates to the ESCO market that is being implemented, and also what the consequences of these changes mean to off-takers and generators, specifically those that have already entered into bilateral agreements. So to kick off, the generators, they will obviously be a market participant in the ESCO markets by definition. The question is, what roles are off-takers going to play? So they obviously have multiple choices of, buying their electricity. The obvious one is the original distributor, where they're purchasing electricity from, which is effectively the no-change scenario. They can engage with retailers, where they buy all of their consumption from aggregators and traders, or they can basically optimize by going bilateral agreements and then buy the difference from retailers and distributors. And lastly, an off-taker can actually become an active market participant, whereas there are two connotations. One is to optimize through bilaterals, or then effectively directly pay in the ESCO markets. We have been obviously always asked around what are the pricing elements and where does the pricing come in the various environments, and it's a very difficult answer to provide, but we want to provide some type of guidance where we think the market pricing would be. So the distributors, they will obviously orient themselves relative to the time of use market structure that we currently have, and they vary obviously from time of use and low season to high season. The retailers will most likely flatten their tariff structure and don't have these peaks in terms of high season. So therefore, their range of pricing will be somewhere between 80 cents and 2 rand per kilowatt hour, depending on the type of methodology of pricing they deploy. Then you've got the bilateral contracts, legacy as well as the upcoming, hopefully all over the OTC market. They will be longer term, therefore, slightly more attractive in terms of the pricing, with less of flexibility in the pricing range. So we would see them to come in somewhere between 60 cents and 1.50 rand. And lastly, the market, it's short term, so there's going to be a substantial variation in pricing. This is all, obviously capped by the cap that is being introduced into the market, and we see that sitting somewhere around the peak tariff of high season. But obviously, we don't know where the lower end of the tariff may be. And, we obviously anticipate that during standard time in midday, with all the solar, being online and have to be reconciled, that the prices are going to drop. So maybe this as the outset. Now, if we move into the topic of the markets, and again, I'm not going to spend too much time on the ESCO markets. That was quite substantially explained by Martin in the previous presentation, but maybe just briefly, intraday and day-ahead market, for this is where ESCOM is playing, intraday being the 6-hour clearing, and the day-ahead including actually the management of the reserves. So obviously there is a space beyond the day-ahead, and this is where our OTC market will fit in. But before I go there, the ESCOM market follows certain objectives. Those are the objectives that are determined in the market code. And just to summarize, it is a space that promotes competition, transparency, and fair trading. And these are the principles that we also apply then for the OTC market. So the OTC market and over-the-counter market basically starts at day 2 and then goes into the future, does not play in the intraday or day-ahead space. And in terms of future, there is effectively no limitation, because that is determined by the market participants that are actually active in the market. These rules, objectives, as indicated, they also apply for the over-the-counter market, and therefore, there is not going to be a substantial difference in terms of how the markets function. So now what we would like to do is basically show an example of the difficulties that some of the bilaterals that have been signed based on the old wheeling structure have to face. And we are trying to also elaborate on how you can actually manage the problems that are created as a result of the market, through an example. The example that we have chosen is actually the customer that has already purchased a substantial amount of embedded solar and has now entered into an additional wheeling agreement to buy electricity over the grid. Typically, the PPAs, as most of them are, in where one way or the other are take-or-pay agreements for renewable. We assume a solar tariff of 90 cents, and we assume that the distributor providing electricity provides it at an average rate of $1.35. On that basis, this customer has bought 30 megawatts of solar, so effectively wheeled in. Now, that creates for him a saving of 43 million Rand, roughly, on an annual basis. Okay. Now, what happens, and this is obviously based on a monthly reconciliation, what happens is that, if you go to an hourly reconciliation, and this is here from midnight to midnight on a day in the month of July as an example, you actually end up in a situation with the consumption curve being the blue surface dropping because of the embedded solar, that, the wheeled-in electricity creates actually an oversupply, at around midday. And that oversupply is effectively, causing now over 20 gigawatt hours of electricity not being fully reconciled and not being able to be used by that customer. What you should have done in anticipation of the market code is effectively downscaling the wheeled electricity to 15 megawatts. Then you would have still gotten a 21.7 million of saving on the first year. Now, quite obviously, he needs to find a solution for the 20 gigawatt hours that he cannot actually buy from the generator. So how to solve it? There are obviously uncooperative ways between generator and off-taker, or there are cooperative ways, and we're just wanting to explore where these scenarios lead to. So the off-taker now has to basically recover somehow the 20.4 gigawatt hours of capacity. I mean, effectively what happens is he can't consume it from the generator. So that's a loss of 18.35 million for him. And he needs to buy the electricity from the distributor at a rate of £1.35. So effectively, his loss here is literally 27.53 million. The generator on his side, he says, well, fine, I have now actually 20 gigawatt hours of electricity. I'll simply dump it on the day-ahead market or on the intraday market. I'll get possibly 60 cents for it. So I've got a benefit of 12.2 million. But on the other hand, the generator has a forecasting risk. And that was one of the questions earlier. How accurate does the forecasting need to be? Well, it sits at 95%, irrespective of the technology. So there's a substantial risk on the generator relative to the forecasting. And we assume that his risk is sitting somewhere around 10%. So that effectively, at let's call it a penalty rate of 60 cents, it gives him an exposure of 3.6 million. This said, he actually comes out on top because he can sell the 12.2 in the market, has a risk of 3.6, so it leaves him with a benefit of 8.6 million. That obviously is going to be disputed then. It's an uncooperative environment, so the consumer will say, well, this is actually my electricity you sold on the platform, so there's going to be a dispute. So effectively, the generator will then sit at a 3.6 million loss. And the the off-taker will actually have a cost of 15.3 million. In both instances, not an optimal scenario. Now, the cooperative way will be slightly different. Here, the generator agrees to sell the electricity on behalf of the off-taker, and he doesn't sell it simply on spot, but he sells it into the OTC market. So what that will then now mean for the off-taker is, he obviously still has a loss of the 27.5 million, but selling it into the long term, into the OTC market, he actually gets sorry guys, I don't know what's happening. He actually gets now a tariff of 80 cents. So there's a substantial difference between those two, 20 cents up. So he actually now gets a benefit of 16.3 million. On that basis, he has set 50% of the forecasting risk of the generator, so 1.8 million. He walks away with a loss of 13 million, and the generator walks away with a loss of 1.8 million. So this is effectively a cooperative approach. In general, it's not a nice, sorry, I don't know what's happening with this screen here. It's not a nice outcome, but it is the optimal outcome under the given circumstance. Okay. Now, the question is, how do you solve actually this problem on a general basis for PPAs? And there are some underlying principles that actually the ESCOM market imposes on the market participants. And that's very simple. It's only the generator that can sell the excess electricity. It's always the off-taker that has to procure the difference of electricity. And there is a vulnerability relative to the generator relative to the forecasting accuracy. Okay, these are the standard rules. They apply to every PPA, whether short or long term. And the workaround of these rules, if people try to do that, is actually causing inefficiencies and higher costs. So therefore, accepting these requirements or these market principles, there is a possibility actually of solving the problems of the mismatch created from going from a monthly to a half to an hourly through a general concept. And we have set that up as IEP already a couple of years ago. We call it the reconciliation procedure because these problems apply to all PPAs. The key principles are effectively that off-takers and generators have representatives, and both representative groups work on common solutions, and they anonymously present these solutions to each other in an iterative process, basically trying to get to a conclusion of what the best accepted outcome will be. There is an adjudicator that is managing the process, and at the end, if there is a gap between those two proposals from either side, the adjudicator will close the gap. So this is a process that actually forces for a solution, and it does that for actually all PPAs that are subjected to the conciliation procedure. The expenses for this conciliation procedure is covered through a fund that everybody chips into, and that allows actually to buy the best experts and whether it's legal or energy, actually to come up with these solutions. So we have this in place for our OTC. We are happy for other participants or other PPA signatories to participate in this conciliation procedure. For us, it's actually a not-for-profit service that IEP renders. We're just trying to facilitate actually the solving of these problems. So this is our sort of our contribution here. But let's move on to the topic of the OTC. Why does OTC make sense? Well, we try to illustrate this in terms of, a small graphic. On the one hand side, you actually have, the trading on the day, and then you obviously have, the trading relative to future contracts or, forward contracts. The volatility short term is obviously substantially high, influenced by, the circumstances of the day. Can almost say if you want to buy solar today, there is no or very little solar available, so this is why the rates are high, right? So, and the more you go into the future, the more prepared are people actually to make, capacity available on consumption as well as on generation, and that's why prices are going to stabilize over time or into the future. The off-takers take an interest to do so because it provides them stability relative to their, short-term and long-term planning of the business. And they are prepared to pay a slight price increase because it gives them actually security on the pricing side, right? And in addition, it actually removes for those corporates that are listed, substantial reporting requirements because, there is always the topic of, well, what happens with, derivative agreements and, what are considered derivative agreements because they are then have to be reported under IAS 37. On the generator side, they will obviously benefit through, allocation of additional capacity, slightly higher prices, and on top of all, also here, the ability to secure funding because you have price stability, over the tenure of the lifetime of the asset. So that is the main reason, why people would want to go into OTC market. It's visibility, price security, and the possibility to plan. Now, I don't want to go too much overboard on the topic of the instruments to be used. That has been substantially covered already by the previous speaker, by Gerhard. But just in a nutshell, to show the complexity when you go into a forward, pricing environment, just showing you here, the above graphic is effectively a 3-month consumption profile that needs to be matched. And obviously we go now into the hourly reconciliation. So these are substantial amount of data points that need to be matched. You can see if you match it with a generation curve, you get substantial overs and unders. And this is why tools in that space are going to be extremely key. Without automation, without data analysis and rules, you will not be able to manage actually this type of environment. That said, these tools are available, and it allows actually, to substantially offset, the variances that you have, partially from your, legacy bilaterals, but also for those to come. So where are we as IEP relative to the OTC market? So in short, we have one. In long, we need to adopt it relative to the new market code. This is something that we are currently doing. So we are reviewing the contract framework. We are planning obviously to integrate into the metering environment of ESCOM, which is extremely essential to actually, get the automation and going. The answer is yes, we are already now in the process of assisting off-takers to manage their over and under because of the reconciliation matters on the hourly basis. We are basically saying to our customers, the market is supposed to be implemented in April 2026. You do want to get ready now. You don't want to be confronted, at the 11th hour with the problem of reconciliation. Now, what is the likelihood of being able to sell actually the overs and unders? We believe it's substantial because, you know, if we estimate actually the PPAs matched in the EIUG space sitting somewhere in the range of 20 terawatt hours. So there's still 40 terawatt hours that are looking for a home only in the EIUG space. And we're not even talking about, you know, the municipal space that, by the way, have to participate in these markets as well. So they are going to dump a substantial amount of capacity into the market. And they also have to participate in OTC, otherwise they're totally exposed in terms of the day-and-day-ahead trading. So maybe I'll stop here. It's the 20 minutes. Chris, I couldn't do it any faster. I tried my best, but here we are.
Well, thank you. Fantastic. Again, another presentation of the highest caliber, explaining the need for longer term over-the-counter market and platforms which IEP provide and which are evolving, you know, to meet this complex environment of short, medium, and longer term procurements. So thank you very much for your input. And it's now my great pleasure to introduce our final presenter for the day, and that is Damian Padachi. Damian is the CEO of Ontech Systems. He's accumulated over 3 decades of experience in the electrical industry across South Africa and Sub-Saharan Africa, and his expertise spans municipal, consulting, parastatal, private sector, manufacturing environments, providing him with a very comprehensive understanding of technology evolutions and the impact on utility decisions affecting end consumers. So throughout his career, Damian has held various senior management positions, and most notably, for several years, he served as the managing director of Itron Metering Solutions and Itron Measurement and Systems for Sub-Saharan Africa. And for the last 9 years, he's been the CEO of Ontech Systems, headquartered in Cape Town. And I think you've seen this evolution, you know, of the different speakers, from Hans Arnold talking about the big picture of the market development and the different components of the market, through to you know, market platforms and services that are necessary to be put in place, that was handled by Force, through to the tools of the trade, you might call it, software tools of the trade, by InnoWeb, and then the over-the-counter market by IEP, and now finally, you know, onto the data management side of things, the metering and data management side, metering data management, by Damian. So it's been a fantastic evolution, and I hope we've covered the subject well, and we're looking forward to your presentation. Damian, over to you.
Thank you, Chris, and good morning to all participants. I believe it's still good morning. We are almost out of the morning. Thank you for giving me the time today, and to the participants as well. My colleagues have given a very good view of the macro environment in the energy sector, which sets a very good context for my presentation. Mine is now the micro view on the demand side. Chris, I know you're running out of time, so I'll do my best to catch up. In recent years, there's been much effort put into initiatives to increase and improve the supply side of the energy equation. This is warranted and should continue. However, there are further opportunities to manage the demand side even better. A lot has been done to increase energy efficiency, and we have seen positive results of these interventions. The meter has, to an extent, been part of the equation. However, with the improvements in metering and telecommunications technologies, there are further benefits to be achieved. The significant difference is how quickly and to what level of control we are able to respond when there's a need for demand reduction. The aim of my presentation is to highlight how smart metering can be used to balance the available supply with demand needs of consumers. This can be done dynamically and proportionate to the consumption of users, rather than a one-size-fits-all approach, as is normally done with fixed capacity load limiting. Time won't allow for a deep dive into technical details, so the focus will be less on products, but rather on desired outcomes. So let's just remind ourselves about the context within which all this is done. The challenges faced by utilities are commonly known to many of us. In essence, it's deciding on the right energy mix to meet the demands of consumers within the constraints of legislation whilst running a financially sustainable business. Achieving the perfect balance between supply and demand is the goal of the utility, but it's not always easy. This is evident when demand exceeds supply and needs to be reduced to avoid a grid collapse. This is when we experience load shedding. As we all know, load shedding has been with us for many years, and it's an uncomfortable reality that we are living with. The impact that it's had on our businesses and households alike has been enormous. Until we resolve the problem completely, we should be trying to minimize the impact on consumers as much as possible. The traditional focus of utilities has been on building, operating, maintaining the network infrastructure, whilst the meter has traditionally been a register of consumption. Now, with the improvement in smart metering and telecommunication technologies, as an example, NB-IoT, there's an opportunity for the meter to play a much more integral part, beyond just being a register of consumption. There's an opportunity for a win-win on the other side of the meter, which is not yet fully tapped. It is true that smart meters have been around for several years. Many of you will know about them and are probably even using them, and that the standard benefits of these devices are being reaped. There is, however, more that can be done, and in fact, to fine-tune, to include more specific use cases relevant to our country's needs. So why the meter, you may ask? Besides the accuracy of static metering technologies and being trusted by both the utility and consumers, the meter functionalities and telecommunication options have advanced significantly in recent years. And these introduced numerous new benefits. Some of the meter features, and I'm speaking of a specific meter in this case, but there may be others that have similar features. But in a more generic way, meters have features that weren't possible before because of telecommunication technology limitations. But with the advancement of telecommunications, it's enabled more functions that can be done, and in fact, more real time. IoT communications now offer lower OpEx costs for point-to-point metering, whilst providing superior connectivity. The enablement of multi-stages of demand management in a meter, in this case, the CAMSTRAP Omnia e-meter, starting with 2 load controls to individually disconnect non-essential circuits, depending on the stage of load shedding required. The ability to control your ampage from 0 to 100 amps to limit the house on non-essential loads is a huge plus. And the automatic reconnection of load after load shedding is over. Those are benefits that we never fully had at the level that we have at the moment. Also, the practicality of targeting disconnections. We also had, hospitals and emergency services that were part of load shedding zones, but because of being part of the same network, weren't able to be excluded. Right? But now with the meter being linked to a specific location, this can be done. So it addresses very practical challenges for utilities. Besides that, it's got calendar features where you can pre-program your load management depending on load shedding schedules, and at moments when you need to shift load between peaks and off-peak times. So with the smart meter, it's like having a permanent flexible switch to control with relative minimal ongoing costs. As with most technologies, and previous speakers have been speaking about it, it revolves around data and the outcomes and the analytics used to make sense of the data. This is also true in this case. As with most technologies, the effectiveness of the outcomes is dependent on the data and the quality of the data used to inform the solution and the analytics used to make sense of the data. The rich insights provided by the meter, coupled with the advanced analytics that are embedded within, allows for more targeted load management when required. There are a number of factors that go into the decision-making for a demand response project, specific to each utility and so forth. But some baseline data is required to understand and optimize the demand response process. This slide shows the typical load profile patterns that have been derived from smart meters, most of which were previously unavailable. The data will inform utilities how to do demand response in a more elegant manner, which is least disruptive to consumers and following the behavioral patterns. The intention is basically to establish the essential load patterns, the non-essential load patterns, as you would see in the graphs, and to adjust all of the above for seasonality and other independent factors. Once completed, the task will be to find the best match to the available supply at that point in time. There are obviously a lot of moving parts, so the answer is not a static one and will vary depending on the situation. But knowing the details behind the data gives you so much more control, where you can adjust your load management according to your consumers' behaviors. This gives an idea of a typical schematic layout of the meter configuration in relation to the network and the load. And as you can see, you have two controls that allow you to eliminate the bigger loads, non-essential loads primarily, and then be able to throttle thereafter. So how does it all come together? When a load management event becomes necessary, either to avoid load shedding or manage a peak demand, a command is sent from the utility's network operations center via the cloud to the meter. The amount of demand response that will be delivered is based on the actual demand at that point in time. So this is based on instantaneous usage. The prior analytics and the past specific usage history is used to calculate the impact and the megawatt production potential. So there's factors that actually do play a role in determining the demand response. The time of day, generally more can be gained from 6 to 10 p.m. During the day and less between 10 and 6 a.m. in the mornings. The days of the week, of course, play a role depending on when your consumption occurs and industries operate. And of course, seasonality, with consumption varying between winter and summer months, like we all know. When an event is triggered, the first priority is given to reducing non-essential loads via the auxiliary switches. Following the logic of the analytics, these will be switched off progressively until the desired load reduction is achieved. It first starts with the auxiliary switch, number 1. Then it moves to the second one. If the load reduction is achieved, then that's where it stops. If it's not achieved, then throttling of the supply would begin within the prescribed ranges. Here, it's also important to note that this will be done whilst also incorporating the individual load patterns of individual meters. For example, if 3 independent consumers are each consuming, let's say, 100 kilowatt hours, 50 kilowatt hours, and 20 kilowatt hours respectively at a point in time, and a 10% reduction is required, each of these consumers will be throttled down to 90, 45, and 18 kilowatt hours respectively. In this way, consumers will still have the supply available proportionate to his usage and with minimal impact as possible. So it's a very practical and a very, let's say, a real solution, minimizing the impact on households, as opposed to having a single limit across all bands. The throttling ranges are typically between 50 to 100%, 100% being full power with no demand response measures, and 50% being the, let's say, the expected range, although it can vary and go lower. Now, post the event and following successful load reduction, it's also important to manage the comeback load of the same target group. Now, bearing in mind, often when you have a load shedding event, there's devices go down, and thereafter, when they come back, they all come back together, right? Typical example would be your geysers, PV battery packs, and air conditionings, and so forth. And when the power is restored, there's a sudden spike in demand, and which can sometimes cause the network to trip again, much to the annoyance of consumers and the utility. To prevent damage to the networks, the reconnection of the non-essential loads will be done randomly, preventing high peak currents on the return of supply. So the ability to do that is also built into the solution. So the throttle range is allowable being 50 to 100, right? We spoke about 100 being normal usage and 50 being half usage in place, right? So we expect that most consumers or most utilities would be able to work within that range, okay? So this diagram provides a high-level overview of how all the pieces come together in an automated manner to achieve the desired load reduction objective within a relatively short space of time. So typically what we're speaking about is 10 minutes or thereabouts. Because when you have an event, you need to be able to react quite quickly to drop your load, or else load shedding becomes inevitable. So not going into specific details of products, but from an OnTech perspective, the components of the solution are housed within a suite of products, meeting the relevant IT, data security, and metering industry standards. This is to ensure that all bases are covered and delivered in a robust solution. Basically, a one-stop solution all in one, a black box. It's also important that as part of the solution, measurement and verification mechanisms or functions are established to validate the proper oversight of the demand response initiative. In essence, you want to measure and confirm that what you are doing is achieving the objective according to your demand. For us, it's been about partnerships with companies that we are working with to achieve outcomes. Karibo and Chemstrap are in that mix, and we found that to be very successful. And in general, in the industry, we expect that more partnerships would deliver more benefits. At the end, it all boils down to understanding the dynamics of one's business and making the right choices and making them now, so you don't have regrets later on. Thank you for your time, and over to you, Chris.
Thank you, Damien. And I think everybody can see how, from the macro level down to the micro and very granular level, ICT technology solutions are impacting the power electrical engineering sector and the power delivery sector really dramatically. And we see how digitalization right down into the consumer's house, providing solutions that benefit the consumer, hopefully, ultimately, but also, optimize, scarce generation, transmission, distribution, network, assets, and to use them in a more optimized way, which ultimately is for the benefit of the customer in terms of getting the best cost structure, the lowest cost structure to meet the objectives by sharing, resources. As a message to me is the strong need, to integrate this properly and not to simply go off the grid, because going off grid means is not an optimal solution economically necessarily, if one can share these economic resources or these infrastructure resources across a wide range of customers. And I think, Damien, you've shown us how digitalization and ICT technologies are actually part of the revolution that is underway in the power sector, from generation right through to the customer's house. So thank you very much for that enlightening presentation. And I also want to thank our presenters for answering so many of the questions online. There are only 2 questions that remain outstanding, and I'm going to not answer them directly, because I think this gives us a great opportunity to ask our participants who would like to ask verbal questions to put up your hands. Those 2 questions that have been asked in text format, I'm sure our presenters will give answers to those online. But let's take this opportunity in the next 25 minutes to handle some questions from you, the attendees. And I'm going to ask you to put up your hand. I will see that your hand is up, and I will come to you and ask you to pose your questions to one or other of the presenters. So anybody who has got a question that they'd like to pose, please put up your hand now. I don't see any up at the moment, which indicates that have all your questions been answered? I think, I'm sure there should be some questions still to be answered. Anyway, I'm still waiting for what I call the hands uppers. Perhaps in the meantime, while we wait, I can just mention a particular thought that I had, and that was, one of the things that this ICT brings to the table is the ability to scale up these solutions. In other words, you can start with an ICT solution that is aimed to solve, the needs of 1 or 2 or 3 or 10 or 20 customers, and to try it out and to test it and to get it working properly. And once it can be scaled up to thousands, if not millions, of customers. So the ability to scale up a solution seems to me to be a very powerful aspect of these ICT technology solutions. When you're talking about a market, if you start off with the big customers, but then it can be scaled down to medium size, and then even down to residential customers who can participate in retail electricity markets and retail arrangements. But okay, I see one hand up, and that is from David Serfontein. David is a regular participant on our webinars, so welcome to you, David. I'm going to allow you to speak at the moment, so please, you're online, and put on your microphone and ask your question. Thanks, David. I see your microphone is not yet on, David. Please switch your mic on and ask your question. All right, fire away, David. Okay, I'm not hearing David's question. So let us, in the meantime, go on to...
Can you hear me now?
Yes, I can hear you, David.
Right,
fire away.
Thank you. I'm asking about demand response. So the British have got a great scheme of, we pay you so much a year, and then you will be part of this demand response scheme, and you can work out how much you are going to earn and so on. What is the reward system, and what is the best reward systems for South Africa? Because I can see there's a lot of money to be saved in that, but people also will not install these technologies and go into this whole thing if there's not a good incentive for them. So that's my question.
Right. I'm going to pose this question to Gerard. Gerard has got some solutions directly related to demand response, and then I'm going to ask also Damien to perhaps come in and give a comment. So Gerard, over to you to answer David's question.
Yeah, I don't think I can give a good answer, but we've had a little bit of exposure to, I think there was a program in transmission, or was due to be rolled out by transmission, I think middle last year, and Eskom distribution as well, as part of the DSM, demand management type of programs. I think they sort of came out of that space, and there were some initial publications, I think, adverts on the Eskom website for the types of rates, rand per megawatt type of rates. I think there was energy and demand sort of components associated with it. I can't remember the details. I don't know if any of the other presenters can, but I do remember us building some of the business cases around it. And it started to look at a household level. We did some of the modeling at a household level, whether a household could fund its smart meter and still get, a little bit back, because now there's the smart meter and the communications, and you have to be able to get a business case going if you're going to put these technologies in, so that at least the household would win, could get something out of it, given the little bit of, I think we were looking at geyser stuff, and then also with, batteries and the solar sort of storage capability that's in households at the moment. And the result from the business cases was it was starting to look very promising. I think the payback periods were sort of a year to 2, that sort of in that sort of space. So anything beyond that would start making sense, at a household level. At commercial and industrial level, I think those programs, I'm not aware of the Eskom programs, but whether they were stopped or not. But at that level, I think there are programs that do that. So this is real. I don't know if that gives you your answer. On the participation side, the systems are available, the aggregators, the communications. I think when it gets into sort of millions, then the communication infrastructures, do become challenging. It's just not easy. You can do it, but if it's hundreds or thousands or even tens of thousands, then the sort of normal stuff works, in terms of API, integration and metadata collection and signaling and stuff. But I think when it gets to many millions, then I think it's more in Damien's sort of space where I don't know if someone else can give a better answer than that. Yeah.
Yeah, Damien, before I come to you, I see Hans Harold would like to come in here, and perhaps I can go to you, Hans Harold. Is your hand up? Would you like to make a contribution on this point?
Yeah, but again, I think there are examples. So you said it in my introduction, so I was on the board of Nodes, which is actually a flexibility service provider or flexibility market operator for essentially providing a market solution for exactly this. So, but the key here, without going into details on that, the key is that there needs to be a proper incentive for people, and I think Francis have a question on the Q&A as well. Why would you allow somebody to get behind your meter and control your stuff? And it's money, right? So if you can save money or earn money of providing access to your equipment, then you might do it. So it really comes down to this. And also, of course, the regulatory framework needs to be in place to support this, which I know is a huge debate in South Africa at the moment on solar and the equipment that we install behind your meter. But again, with the proper regulatory framework, again, as Harald said, the technology is there. It's easy to implement in a sense if you get the proper regulatory framework.
Damien, can I ask you to come in here? And I think the point is that, yeah, Hans Harold has mentioned, it's all about the money. If you give people an incentive, they can, they will allow you into their house to control their loads. But it seems to me a very one-sided arrangement at the moment. The utility is looking for benefits to itself, but there doesn't seem to be any mechanism of compensating customers for for helping the utility reduce demand, by throttling or by switching off a load, and there seemed to be a lack of bilateral benefit. What are your thoughts, Damien?
Yeah, so thanks, Chris, for that. Yeah, this is a tricky one. So the one benefit, of course, is that as a consumer, if you want to have some supply, you want to have some energy, and in fact, not some, a lot, compared to a complete switch off, that in itself is an incentive, right? To be avoiding a load shedding event. In some cases, the Munich could couple that with an incentive financially, and that's a more trickier one, and it's quite a deep and long rabbit hole, but that's possible and not too, let's say, readily available in SA specifically. But then for consumers that have PV, there's a cost in doing your installations and so forth. And sometimes a slight deviation is that you might think, I've got my PV, I'm all good and so forth. But when you have a load shedding event and you switch, to grid to charge your batteries, you're basically impacting the grid as well. So you have a part to play. And that part basically is where you can, with the utility, avoid being switched off again, whether it's bad, whatever it might be. Point is, there's an equation where it's balancing between one and the other. And then the other part about the device is it's a 4-quadrant meter. So it allows for reverse energy measurement. So if you want to export, the ability is there, right? It's all dependent on the utility, whether they allow it and whatever the rules and regulations are. But the possibility to navigate these things are within the, let's say, the legal framework of each utility.
Yeah, thanks. And I hope that answers your question too, Francis Jackson. Why would you allow, the utility into your house to control and know what you're doing? Because there, in fact, may not be a direct financial benefit, but there are benefits of reduced load shedding. What I just want to say is I just wish, there's obviously incentives are necessary, but there's also penalties that are necessary, in my view. I mean, I get charged a fixed cost by my municipality per month for network access, even when I don't have network access, for many hours of the month due to load shedding or cable theft or whatever. But yet I have to pay for that fixed cost, which I feel sometimes I'm paying for something that they are failing to deliver. I just find the relationship between the supplier and the customer to be somewhat one-sided, and I guess that's due to the monopoly history of the arrangement. And hopefully that will change as as retail competition enters the equation. But so thanks for that, and I think Francis, that may have answered your question too. I do see Mike Barker's hand up. So Mike, I'm going to allow you to talk now. Please switch on your microphone and ask your question.
Yeah, thanks, Chris. Question for Damien and the team. The Californian Energy Commission has got something called MIDAS. It's the Market Informed Demand Automation Server. And that provides access to the utilities, time-varying rates, and of course, greenhouse gas emissions, and probably most importantly, what they call the flex alert. In other words, when you want your consumers to dial down. Now, the interesting thing is not everybody's connected to the internet, but they are making use of the FM radio system, which is ubiquitous throughout South Africa, as you know. And the RDS, which is, I understand, a communication protocol running on one of the sidebands, can push information out, not bidirectional, but omnidirectional, unidirectional. This information can be transmitted via the RDS chips. Now, these chipsets are dirt cheap. You can buy a breakout board for about 100 Rand or less. If you go into Temu, you can get them from China for the receivers for 20, 30 Rand. So the question is it not possible in South Africa to set up something like this MIDAS server to push out data, not only flex alerts, but real-time rates, and especially the greenhouse gas emission signals, and push that out to the meters? Because I'm sure this can be used much like Damien was showing us, but instead of an internet connection, which needs quite a extensive communication stack. Thank you.
Yeah, fascinating, Mike, for those insights. And it obviously points to some great opportunities for innovative tech entrepreneurs, young, clever people that can take advantage of these technologies and provide solutions. So I really look forward to these tech entrepreneurs out there, these guys, smart, clever guys coming out of our electrical engineering and computer engineering universities, taking advantage of this, working together with people like Damien and others, people that supply smart inverters, smart batteries, and all of this kind of stuff, so that we can really get smart about these things. But would you like to respond to anything, Damien, or Martin, for that matter, if you would like to come in here and make any comments? First of all, Damien.
Yeah, thanks, Chris. And I think it's a very good point. It's more, I think, an item that we could learn from. I'm not familiar with that model that's been spoken about, but certainly one that we can incorporate into our side. And just maybe an extension of that as well is, from a consumer perspective, having access to the data besides the usage that has been explained now, there's an opportunity, if you know your profile of your data, to shift your load accordingly. If there's a time of use tariff being applied, shift it to a zone outside the high tariffs and so forth. So there's so many benefits from that. So, I mean, that can go on, but really it puts more control back into the hands of the consumer with visibility via the apps that are available to manage and control accordingly. But
thank you. Martin, would you like to come in here with any comments about real-time pricing and access to utilities data, the other way around from utility access into the homes data?
And to be honest, I think this is a question, it's a very interesting question, a very technical question, but it's a bit off from the market and market designs. So I was listening very careful, and it's an interesting approach, but I think it's a bit too much off from in a way that I can give a really helpful answer here.
No problem at all. Thanks. Okay, look, there's another question who's got his hand up. Tinus, if you would like to switch on your microphone at this point and ask your question.
Hi, Chris. Can you guys hear me?
Yes, loud and clear. Thank you.
It's good to see you behind the webcam again. I hope your health is also doing good, Chris. We always enjoy your webinars. Really fascinating. So I just see in the questions a couple of questions about the imbalance calculations, and if people do funky stuff, and what will happen then? What's the penalties involved? I don't know if you guys could please elaborate on that. I guess Hans would be the best to inform us on the market code, but yeah, just some more detail on that I think would be beneficial. Thanks, Hans.
Thank you. Well, let's try Martin on this one, because it might be more up his street, and then we'll go to Hans as well. But I want to give everyone a chance to make input. Martin, yeah, can you give us your thoughts on this?
Sure. So yes, indeed, Tinus, there is or the market design caters for imbalance cost calculation. And there is clear rules and also formulas how this will be done at the very end. So that's why it's very important that you submit a forecast on your generation that is as close as possible to what you at the end actually produce or actually consume. And I mean, I can give you an example also from Germany, where it's maybe not done in the best way. The country here is every year has billions and billions of euros to be paid by the end by taxpayers also, because there's a lot of imbalances that come from the huge renewable penetration. So not necessarily from inaccurate forecasts on consumption and the generation, but in general it just shows that it's important that you have a mechanism for imbalance cost calculation, but also need to have the right incentives and the regulatory framework in order to avoid having imbalances, and having good forecast generation or consumption forecast is important, but it requires more in order to keep imbalance costs low. That's my comment on it. And if you want to chip in there, Hans.
Hans, do you want to chip in here?
Yeah, but again, I think Martin has said the main thing. I think with balance responsibility, which is part of the let's say regulatory framework for an imbalance, is essentially making sure. So again, that if you are sloppy with your forecasts, or if you are sloppy with your how you are buying or selling or offering to buy or sell, then and you're not able to honor that, then it will be kind of punished, if I can call it that, through the imbalance, and then you lose money. So the whole thing about imbalance and imbalance calculations is that it's a financial penalty for let's say imperfections, and of course you will never be 100% correct. But again, this is why we also very often say why trading is an important skill. Kind of that again, if you are good at this, you'll earn more money than the bad one. That's kind of the. So it's or it should be a proper financial instrument to ensure people are doing the best they can, because that is also then the best for the market and for everybody.
Yeah. Thanks, Hans. I'd like to just ask Holger, to come in here and say, this is a question really from me, and that is, how does like a customer decide how to, balance, some legacy is obviously legacy suppliers and legacy arrangements with distributors. There is the over-the-counter market, and there is the the day-ahead market, etc. Is it a case that you need to balance and hedge your risks over all three of these arrangements, whether they're the legacy arrangement, the over-the-counter, and the day ahead. And how do you see the balance between between these? Obviously, I guess it depends on the customer. Every customer is different, but how do you see the balance between these three markets?
Well, as you say, it depends very much on the type of customer. You can argue that for customers like certain EAUG members, the electricity consumption makes up, line item number 2 in terms of their P&L, in which case, it would require effectively almost to establish a trading desk to make sure that you actually buy the best electricity, in which case then you have a staggered risk mitigation approach by effectively buying some of the electricity long-term, over an OTC market, and then possibly stagger that, go 20 years, 15, 10, and 5. And then you have, the shorter-term electricity that you may want to optimize, through, the day-ahead market on Eskom. So that would be one strategy. Another strategy would effectively be, this differential that you will always be sitting with to, have, covered that by either the retailers or effectively your local distributor. And that's pretty much a function actually of how much exposure do you want to have in the market, whether you want to fall into, if I may call it, the reporting gap that you may have in terms of IFRS. Or whether you consider it, reasonable enough to go into that space to do further cost optimization. Suppose it's also a question of how stable your consumption curve is, because if you have a stability in that sense, then you can possibly actually put most of the risk of imbalancing or variation onto the generator.
Thanks. I think we're going to take our last question now because it's 27 minutes past 12. There are no hands that are currently up at the moment, but there's a question here I see, which I think is an interesting question from Marcel, and he asks the following, and I don't know who to pose this to because it's something of a hot potato. But Hans, Hans Harold, I'm going to put it to you because you're at the heart of things and probably know something, have something to say about this. But the question is, will the SMO systems market operator, and for that matter, will the NTCA itself ever be independent enough from Eskom and from government and not to favor Eskom generation above IPPs in South Africa? It gets to this question, is the NTCSA obviously it's a subsidiary of Eskom Holdings, and there seems to be a bit of uncertainty out there as to Eskom's intentions and even government's intentions, with some conflicting messages coming out, is whether or not the NTCSA is going to become fully independent of Eskom to be able to perform its role as an independent transmission system and market operator on level playing fields, allowing competition on a non-discriminatory basis with all generators, not biased towards Eskom generators. I know it's a hot potato, but I really would value your thoughts about the independence of the NTCSA going forward.
Yeah, but I think of course, this is this perception, and I think this is a perception that exists. And again, not to put anybody on the spot, but I, for instance, hear Holger saying the Eskom market and not the NTCSA market, for instance, which is kind of which is also true, right? Because it is managed by Eskom Holdings, kind of ultimately. So the answer to this is simple and as hard as they need to establish a trust that they are independent. And one of the key things is point one: we need to have or will have a market code that needs to be enforced. That's kind of point number one, kind of to have a strong regulatory setup, and that NERSA and others are authorized, let's say, or have sufficient authority to make sure that everybody, including the market operator, because remember, and I think this is an important part of the market code, is that a lot of the rules and regulations are also covering the operation of the market by the market operator, right? So not only market participants. And I think the second part of this is transparency. So I know from the market point of view, it's rather clear what transparency is required from the market operator. As I've also now been helping the CPA a bit over the last months, we have also proposed some rules for the CPA where transparency on the vesting contracts with Eskom should also be given to the market. So essentially, people should be aware of what vesting contracts that Eskom Generation will have for all his whole fleet, and Eskom Distribution and other licensed distributors will have on the other side, so that everybody should be able to follow what is happening and raise their arm if they think that Eskom or anybody else is given preferential treatment. So it's as easy and as hard as that kind of that. Again, they need to earn their trust. So because this will always be the case that people will question is there true independence, and probably won't help either if the MTCSA is fully unbundled, that people will say that, oh no, there are some strings behind the scene here that connects the old Eskom. So yeah, again and again, let me end with this kind of, you always say that South Africa is so special. Yes, you are a bit special, but not that special. So these are issues that have come up in almost any market. A joke with Germany again. So in the German market for a very long time, RWE, as one of the biggest market participants, was always granted the chairman of the market operator in the market operator board. So again, you will see these other places as well. So.
Well, thank you, Hans, for that very, I think, mature and balanced response by an expert to what can be sometimes a tricky question. But I think you gave us a clear, frank answer that I think is mature and balanced. So look, with that, I'm going to draw a close to this webinar. And in the first instance, I would like to thank the companies that have supported this webinar, and that is Bredensen Consulting, Hans Arold himself, Fors in Germany, EnerWeb in South Africa, OnTech in South Africa, and the Independent Energy Pool based in Switzerland but active in South Africa. Your companies are making a big contribution to South Africa and the market evolution and the technology solutions that are needed as we move forward into this new space of digitalization of the electricity sector. Thanks also to Martin and Gerard and Holger and Damien and Hans Arold for their contributions and presentations. Absolutely fantastic. I think this has added a lot of value and explained to people like me and hundreds of others who attended and who will be watching the video as to what the opportunities and solutions are out there to the pressing problems. Thanks also to our audience for joining us today, and those who are not able to join us, who will receive the feedback reports and the presentations and the video tomorrow. Thanks for your interest. Thanks for your participation. And keep your eyes open, please, for our next webinar, which I expect at the end of this month of April, which will be announced, I hope, in the next few days. And it's been great to have everybody here. All the best from me, and look forward to seeing you again. Cheers.